Hello and welcome to this session of Learn IT Courses Online. We're very glad that you're joining us again as we continue in our database administration introductory course. As you mentioned, when it comes to database and data, there's different positions from which we encounter and work with. There's the SQL part of it, there's database design, security, performance, troubleshooting, installation, most of which fall under the database administrator's realm, and then there is the ETL and the reporting. Today we're going to talk about something that's very core and important, which is the database design part of it. Database design. One thing that we're more than definitely going to hear about is the importance of a well-designed database. Again, I'm just going to run through it real quick. Then we're going to look at actual design, and then we're going to go back to the notes, and it's going to make a lot more sense. But through the years, as different projects have been developed and databases have been designed, database administrators, people that design the data modelers, and different people that work and develop and run reports and SQL against the database and get data and insert and load data, have found out that there are certain standards, group of standards, that allow us to have a better, well-designed database. For example, a table should have an identifier. A table should store only data for a single type of entity. A table should avoid nullable columns. A table should not have repeating values or columns. We found over the years that the more we have those kind of standards, that we're able to insert data faster and query data faster and see it, and it makes more sense, a lot more advantages as well. So that concept became known as normalization. Normalization is the logical design of the database, including the tables and the relationships between them, to ensure that we have an optimal or optimized relational database. One thing that's definitely going to come in an interview, if you're applying for a data modeler or database administrator's position on database design, is what is normalization and what are the different forms or levels and forms of normalization. And that's where we get into the different levels: the first normal form, the second, the third, the fourth, describing that with the first one we eliminate any duplicate columns from the table, and then the second one we remove subsets of data that apply to multiple rows, and then the third one remove columns that are not dependent upon the primary key, and then the fourth one a relationship in the fourth normal form has no multi-valued dependencies. So those are the kind of things that we need to have practiced and memorized so that we can go to an interview and definitely be able to answer anything that's normalization related. And of course, what are the benefits? And then there are a few benefits. But a lot of this will not make sense if you do not practice it. So I'd like you to join me here in a moment to kind of look at a design of a database and how we reap those benefits of normalization. And then the whole thing is going to make a lot more sense. On the upper part of the screen, I have a table, as you can see, a database called the Coolest Bank. And then there's a table called Bank Customer. And as I select all the records, the 4 records that we have in there, we have our customer's name, Mike Tyson, who lives in 101 Boxing Street, Las Vegas, Nevada, zip code 88901, area code, email, account type is he has a checking account with us. Here's the transactions that they've had: a deposit, a withdrawal, a transfer, a withdrawal, and then the amounts of each transaction, and then the dates. So on January 1st of 2018, January 2nd of 2018, and on January 3rd, there's actually 2 transactions, transfer and a withdrawal. And I have the same information in Excel. In Excel, this is something that we might find, and that's what we call a flat file, where everything is just stored in one big fat file that has all the information. So as we notice, there is a number of things here. The first one is you would see that there's some information that changes. So with each transaction, I'm having different amounts: $4,500, $3,200, 99 cents, $900, $400. Transaction type might change: deposit, withdrawal, transfer, withdrawal. The dates change. But notice with each entry, the name repeats because it's for the same person. The address repeats because it's for the same person. The city is still the same related to the address. The state, the zip code, the telephone number. So the first thing that happens in a relational database, because in the relation database, unlike a flat file, in a flat file, if I was to have two Excel sheets or two flat files, there's no way I can go into one file and pull in information and relate it to another one. But in a relational database, I'm able to have multiple files. And when a file is stored in a database, it's called a table. I can have multiple tables, and I can have a relationship between them. So it's very easy for me to get that information from one table that's related to another table, as long as I build that relationship between them. So it then makes sense for me to, instead of repeating this information over and over for each new entry, for each new transaction, that I can have it one time in one place, in one table, all by itself. So the first thing is not having duplicate data. There's a lot of advantages for not having duplicate data. For instance, just to oversimplify it, let's assume that each letter that's stored in the database takes 1 meg, just to oversimplify the numbers. So if I was to have Mike Tyson, that's 1, 2, 3, 4, including the space, 5, 6, 7, 8, 9, 10. So if each letter takes 1 meg, then I've just used 10 megs. And then I've repeated it 4 times, so I have 40 megs. And now multiply that by all this information that's all duplicates. So all this information is repeated that many times unnecessarily. And now I probably have, let's say, about 40, a few hundred megs that are consumed, assuming, again, we're exaggerating the numbers, but a few hundred megs of wasted space. So the first thing that happens when I group things together and not have to duplicate it is I'm saving a lot of storage. And now when we're dealing with millions of transactions and even billions of transactions in some cases, then we're definitely saving a lot of storage. So that's one great advantage of grouping our information or normalizing our tables and the relationships. Another advantage is data entry, because if someone is going to enter this information every single time and it's repeated, chances are one of those times they're going to mistype the name or mistype anything in the address or the city or the state or the zip code. So also it's going to help us with data entry and accuracy. Again, the amount of data entry that's happening for duplicate data, if you have someone that's actually in the office doing the data entry, they're quadrupling in this case, about 4 times the work that they need to do versus having done that entry one time in something that's related. So we really save a lot of costs, whether it's in storage, whether it's with data accuracy because of not trying to duplicate data entries, and also in terms of pay of employees, that we're not focused on duplicating data entry, but centralizing it. So there's a lot of advantages and benefits of doing that. One of the most important things as a database administrator or data modeler that we care about as well is performance. Performance means when I have 4 records, it's going to take me much longer to query my data than it takes me to pull just 1 record. Now multiply this with tables that have millions of records. When we're talking about transactions and banks that have, for example, in the case of the coolest bank, we would have hundreds of thousands of customers and millions of transactions on weekly. Just imagine one of our customers could be a company that has to do payroll. So we're handling all this payroll and deposits and withdrawals and pay and so on and transfers. And so we're talking about millions of transactions a year. So again, pulling that information that's duplicate unnecessarily versus one row that just has it is going to save us in terms of performance. Performance means getting that data much faster to the user, running reports and getting the data faster, or even data entry, because now we don't have to worry about multiple records. So there's a lot of advantages of grouping that information. How do we go about grouping it? A lot of times we'll not be as lucky as we are this time around, where we have names that are spelled out very clearly to us to see the relationship, but we would need to kind of see what entities or what relationships go together. Now let's notice something. Let's look at this data and see what could be grouped together. Notice that the first column is the customer's name. So it's customer related. The second one is the customer address. So it's, again, customer related. The customer city, where they live. So it's customer related. The customer state, which is kind of related to the customer as well. And then the customer zip code, where they live, their residence. And the customer telephone number and customer email. So all this information links back to the customer. The second thing is, or the second group of columns relate to something else. Well, we have an account type. So this is kind of account related information. the account transaction type, which again is kind of related to the account, the account transaction amount, which again is related to the account, and the account transaction date. So this is more related to the account. And then there's a relationship between the account and the customer, because each account is owned by a customer. So now let's see how we can create or recreate this table into two tables that's going to save us. Again, we can break it into more detail, but for now we're just going to simplify it and break it into two tables and see how that's going to help us in the concepts of normalization. So we'll go to our database diagram, create a new database diagram. It's the first time we're creating it, so we're prompted. We'll click yes. We're not going to add this table, so we're going to close. And we want to create two tables, one for the customer and one for the account. So right click, new table. The first one's going to be the customer table. And then the second table is going to be the account table. Okay. Rule number one is always let's have the first column as a standard to be an ID column. So what we're going to do is we're going to have a customer ID column, and we're going to make it numeric, just integer. And we're also going to do something cool. So the first customer is number one, the second customer is going to be number two, the third one is going to be number three, even though that's not required here, but to kind of have our own little standard, it's going to help us in the future if we need to query stuff or look up stuff or count stuff. So what we're going to do is right click and look at the properties, and then we're going to look identity specification. Yes. So the first one is going to be employee number one, and then it's going to increment automatically. So I don't have to enter the employee numbers or the customer numbers as 1, 2, and 3, but it's going to keep incrementing by itself. And again, first column is going to be the table name ID, so it's going to be account ID. It's going to be an integer, so it could auto increment. We're going to look at the properties. And starting at 1, incrementing by 1. So now each time I enter account information, the first account is going to be account number 1, the next one number 2, and number 3. All right. The second thing is I want to make sure I have a relationship between this table and this table. So before I even enter any of those columns, let me go ahead and make sure I have a customer ID here. So I'm going to go ahead and add customer ID as an integer. And then we'll set this as our primary key on this table. And this is the primary key in this table. And we want to create a relationship between this column and this column. So in here, it's in state, or in the country, or in the vicinity, so it's a primary key. But once it travels overseas, it becomes a foreigner. So this is a primary key, and here it's a foreign key. So when I drag, click and drag and drop it over here, it's going to prompt me and says, I'm going to create a new foreign key relationship. Customer ID on the customer table is a primary key, but customer ID on the foreign key, on the account table is a foreign key. Is that what you want? Yes. Okay. And now I created a relationship between the customer ID here and here. Okay. Now we can go ahead and enter that customer information. So we can enter the customer name. We'll do that as a varchar. And then the customer address as a varchar. We can enter the rest of the information, but for now we'll just run some of the other stuff. Account type, varchar. Okay, so at this point we have our customer table that has the customer related information. We have the account table that has the account related information. We have a relationship between them, which is on the customer ID, which is a primary key here and a foreign key here. And then each table has the first column as an ID, which is its own primary key. Let's go ahead and create those tables. Click yes. So now we do a refresh. We should have our new tables. So now when I go into the customer table, I don't have to enter the information 4 times. I merely enter it 1 time. So notice I only entered the information 1 time for Mr. Mike Tyson. And when I save it, of course, customer ID is going to be number 1. Okay. So number 1, the information is just entered 1 time. Now we can go into the count. And we're probably, by the time we create it, are going to have 4 IDs for that information. But then the account ID, all I have to enter is 1, and it knows that all this information is related to customer number 1, which is Mike Tyson. Now notice for the account information, we've only entered customer ID number 1, but it knows by default that that's all of this customer information, the customer name, address, customer city, customer state, because there is that relationship as a foreign key. It's a primary key in another table, which has all the details of it. So I don't have to no longer enter that information of name, address, city, state, zip code, telephone, email, and duplicate it each time. All I need is just a single reference of 1, and it knows to get that information from my customer table. One thing that's really nice about having that relationship, a foreign key and a primary key in addition to that, that's going to make our life easier, is I don't have to create a select statement and build it with the join. I can have SQL Server do it because in the data dictionary, it already has that information built in. So I can go to Design Query and Editor and say that I'm interested in getting information from the customer and the account table. Notice how it automatically built that relationship because it already knows foreign key, primary key. So I want to get the customer name, their address, their city, their telephone number, and I'd like to have the transaction type and the transaction amount. So let's go ahead and check on those. And it builds it for me because it already knows that there is a relationship on account customer ID and the customer ID in the customer table. Click OK, writes it up, execute, and it gets me that information. Didn't have to duplicate it in data entry and waste storage and slow down my queries, but when I query it, I can get that information in any format that I want. And that is what makes normalization very convenient and very beneficial. So now the mumbo jumbo that we talked about at the beginning probably makes a little bit more sense. That a table should have an identifier. A table should store only data for a single type of entity. A table should avoid nullable columns. A table should not have repeating values or columns. And that process of organizing it, designing it, is called normalization, which is the logical design of the database, including the tables and the relationships between them. And it's the core of optimized relational databases. And then the 4 levels of or forms of normalization, which includes in the first one eliminating duplicative columns, removing repetitive groups, creating a primary key on the second one, remove subsets of data that apply to multiple rows of a table and place them in separate tables, create relationships between these new tables and their predecessors through the use of foreign keys. On the third one, meet all the requirements of the second normal, but in addition to that, remove columns that are not dependent upon the primary key. And then number 4, if a primary key is composed of multiple columns, then all non-key attributes should be derived from the full primary key only. If some non-key attribute can be derived from partial primary key, then remove them. And as we said, there's a number of benefits of normalization, which include faster sorting and index creation, because now I have less data, a large number of clustered indexes, narrower and more compact indexes, fewer indexes per table, fewer null values, and less opportunity for inconsistency. So I'd like to thank you again for this opportunity of joining us at Learn IT Courses Online as we continue our journey with the introduction to database administration and data courses. Thank you.